Valence electrons define chemical properties of elements. That is why we always keep track of them. In Bohr's model in numerical electron configuration, sodium has one valence electron, phosphorus has 5 valence electrons. Here is an easy way to represent it. Symbol of sodium and one dot next to it. Symbol of phosphorus and 5 dots next to it. Imagine a square around each symbol. Each side of the square represents an orbital of valence shell, 4 sides, 4 orbitals. We cannot place more than 2 electrons on one orbital, so maximum of 2 electrons on one side of the imaginary square. This representation of valence electrons is called Lewis dot structure, and it focuses on representing only valence shell of atoms and ions. When we are drawing Lewis dot structure, we ignore core electrons and represent only valence shell. Imagine a square around symbol. Each side of the square represents an orbital of a valence shell. 4 sides, 4 orbitals. We cannot place more than 2 electrons to one orbital, so maximum of 2 dots or 2 valence electrons on one side of the square. Since s orbital of valence shell fills up before p orbitals start to receive electrons, first 2 dots that represent valence electrons go together on the same side of the imaginary box. The rest of the electrons go unpaired as long as there is room for it. Neon has 8 valence electrons. Imagine a square around the symbol of neon and start placing valence electrons. First 2 electrons go together on the same side of the imaginary square. The rest of the electrons go unpaired, but we soon will run out of unpaired options. Then electrons would have to pair up on the orbitals. Eventually, neon will have a full octet of the valence shell, the arrangement that makes it to be an unreactive noble gas it is. Beryllium, magnesium, and calcium are elements from group number 2. As such, all of them are going to have 2 valence electrons. Fluorine, chlorine, bromine are elements from group 17. All of them will have 7 valence electrons. Notice that we always start by placing 2 valence electrons together on the same orbital. Then we place electrons in unpaired formation and start to pair them up only when we run out of unpaired places. So we can create a generalized formula of Lewis dot structure for 8 groups of periodic table. X is a placeholder for a symbol of the element from that group, and number and positioning of valence electrons repeats itself for all members of the same group. Similarity of valence shell is why elements of the same group have similar chemical properties.